Good day everyone. So today's topic is preparation of raw material cost contribution sheet for a pharmaceutical product. Today we are going to see how to calculate the raw material cost contribution for a specific product, and the product that we are going to take today is going to have total 3 number of stages. Let's start it. So this is going to be somewhat detailed when compared to the cost contribution sheets which will be prepared by the finance team. Initially, we are going to prepare total 4 columns, the basic 4 columns, and then we are going to extend the remaining things. The first column is raw material, and the second column is volumes or times, and the third column is the units of measurement, and the fourth column is consumption. And the product that we have considered is going to have total 3 number of stages, and the first stage, let's say it is stage X, and the raw materials are going to be A, B, C, D, E, F, and G. So the output for this particular product is X. Output X. That's the reason we have mentioned this as stage X. And let's say this raw material A is going to be the key contribution material. So these volumes are going to be the ratios with respect to the KCM, like the key contribution material. Let's say the initial batch size be 100 kg, and the component B or the component B is going to be 50 kgs, which is consumed in the process. So automatically what will happen is the ratio is going to be 50 divided by 100. So this is nothing but a volumes or times. Similarly, I am going to mention the ratios here. So this is 0.3 and the next one is 0.4. So these are only consideration, and you have to take this from your BPR. 0.2, and let's say this is our reaction solvent, and this is 10 volumes. So the units or measurement is going to be, the first one is in kgs, and this is kgs. Let's say this is in liters. Okay, as we know these ratios, so we are going to straightly calculate these quantities from here. And similarly to these materials, the output is also going to have certain ratio, and the ratio is called as the yield factor. So I'm going to consider this as 0.8 times with respect to the input. So let's do one thing directly. Let's calculate for this and let's drag. Put some dollar symbols and let's just drag it. So for this first stage it is done, and let's go to the second stage. Let's say the second stage is stage Y, and here the main or the key contributing material is going to be X, which is the KCM, J, K, L, and M. So up to M, these are going to be the materials which are being consumed in the process, and the output is going to be Y. And similarly, this is going to be, let's mention about the units of measurement for these materials, and the output is going to be in kgs. And let's say the ratios are going to be 0.5. So these are only considerations. 0.2 and 0.4, 0.3 and 10. And for this output, let's say the yield factor is going to be 1.43 times. And coming to here, so let's say the input is taken as a throughput, means whatever that is being produced in stage X will be taken as input. So, and from here we are going to multiply this with the key contribution material. So key contribution material is nothing but the material which is going to have more elemental contribution towards the product. Okay, so I think even now stage Y is done, and now let's do it for the stage Z. So this is the final stage. So we are going to refer this as a API. Okay, Y, and the output is going to be Z. Okay, let's make a note of these ratios. So most of the products, or sorry, most of the raw materials are going to be in kgs. The solvent is going to be in liter. The output is going to be in kgs. So let's consider the same, like the throughput from the next stage. Sorry, from the previous stage. And let's try to calculate these things from the volumes. But before that, let's try to add up dollar in front of this. So by now, the total thing is done here. Okay. So here, the next column that we want to take is the recovery. Like whenever you are going to prepare a raw material cost contribution sheet, so you should take this recovery also into consideration. Like some of the times you will be using fresh, and some of the times you will be taking the recoveries also. So if any raw material is getting recovered, then take the recovery percent, like the recovery percentage is just consider it. And the next column is deployment. So deployment means the amount of quantity that is being taken considering the recovery also, like how much fresh you are going to take. So since this is KSM, I don't want to recover it. And let's say this component D, I would like to recover almost 80% to the input. And coming to this, I don't want to recover, and this I don't want to recover, but here, sorry, zeros. And this is a solvent, so I'd like to recover it. So total 80% recovery I'm going to do. Okay, and now the thing is deployment. So while making this deployment, the easy thing is, so the total consumption, I mean the total consumption into 1 minus recovery. Okay, so just try to drag it. And similarly, this is the way for the stage 5 also. Since it's a KCM, I don't want to have any recoveries. And coming to the solvent, I'd like to have almost 80 to 90% recovery. As a minimum, I'm going to take 80% recovery. So use the same formula into 1 minus this recovery. And coming to here, the same thing. As I got only one solvent, I'll be recovering this. Sorry, this is, let's say, almost 90% I'm going to recover. Why? Because since this is an API stage, the impurity content is going to be low here, so I'll be recovering almost 90%. So just try to link up everything while preparing a raw material cost contribution sheet. So once the deployment is done, so just make a note of the specific gravity. So while recording this specific gravity, just remember, if it's a solid, just take the specific gravity as 1. Why? Because in the further steps, I would like to take the total weights of these materials in terms of, I would like to consider only the total weights. I don't want any of the raw material quantities in volumes. So for solids, if the units are in kgs, just take it as 1. And if these are in liters, so then just try to consider in, like if it's a liquid, just try to convert this into weight by multiplying with density. So here I have considered some things. If it's a solid, just try to take the quantity of specific gravity as 1, and if it's a liquid, take the actual specific gravities. So here it is 1, and coming to this is in liquid, so I'll consider the density as 1.2, and again this is a liquid, so I'll consider the density as 0.9, and again this is a liquid, so I'll consider the density as 0.79. And here, so these are going to be all solids, so we'll be taking it as 1. And coming to the final thing, let's say the density is 0.902, like the less that we can take. So once it is done, let's calculate the input weight, input quantity in terms of kgs. So this is nothing but the deployment multiplied with the specific gravity. Okay, I'll copy the formula and replicate here. Similarly here also, Control C and Control V. So once this is done, the next column is unit price in rupees. Like what is the price of these things? So these things you have to take from the SEM or PPIC team, and sometimes you can take this from the warehouse also. Since this is a key contribution material, I will be taking this as higher 2000, and these are only considerations. If you want to get a RMCC exactly, then you can take these quantities, sorry, these prices exactly. So I'll hold this for X. Why? Because after calculating here, we have to take it here. The X price. Why? Because we are going to manufacture the stage X in-house. So I'll be leaving it as blank for now, and the remaining things I'll be filling now. And similarly, this is the case for Y also. Here Y is being manufactured in-house, so I'll be leaving it as blank for now. So the prices is done, and the next one is we need to estimate the state CC. So state CC is going to be the ratio of input to output, like the stage wise cost contribution for each raw material that we are going to see. So it is nothing but, so just divide the input quantity in kgs with the output here. So just try to apply dollar and just drag it. Similarly, this is going to be the same, the input quantity divided with the output. Just do one thing, just let's arrange this alignment. And coming to here, this is going to be the same thing for state CC. Just apply dollar to the output and just drag it. So the state CC is done. Now let's see the cost of these materials with respect to state CC. Cost as per state CC, and this is going to be the state CC multiplied with the unit price. So just drag it. Now let's try to add up the total, the summation of the above materials. So this is going to be almost 2664.38. So that means this is the manufacturing cost for stage X, like for 1 kg of material of stage X. So I'll be taking it here, and similarly we have to do with this. And again, this is going to be the summation of the individual costs. So here we got 2270.34. This is the cost. So just try to link it with this. So once this is done, now let's calculate about this. So here it is going to be the summation of the individual prices. So we are done with cost with respect to the state CC of individual materials. The next thing is going to be critical. This is the pharma CC. Like this is going to be equivalent with respect to, we are going to consider from the pharma end. And to calculate this, we have to do the back calculation. That means we have to come from the last stage. So this is going to be Like for pharma stage, the stage CC equals to pharma CC. So just drag it. And coming to here, so the pharma CC is going to be the stage CC of this material multiplied with the pharma CC of the key contributing material in the APS stage. Okay, just remember this. So let's add up $1 for the pharma. Okay, and drag it. And now coming to this thing, this is going to be same. So the stage CC multiplied with the last stage pharma CC of key contributing material. Okay, and just apply dollar for this previous stage KCM. Just drag it. And now let's calculate the cost as per pharma CC. So CC is nothing but a cost contribution. So this is nothing but the pharma CC multiplied with the price. Just drag it. Similarly, this is the case of the next stage also. Let's try to add up here. So here it is already limited to 2 digits, and now we need to cross check whether the calculation is right or not. In order to cross check that, what you have to do is you just try to add up these things. Okay, so whatever the pharmaceutical cost contributions are there, the individual raw material cost contribution, just try to add up it. Why? Because this particular 2837 is going to resemble the summation of these, and here the 2329 of x is going to resemble the summation of these things. So just try to add up here only the last things. See, now these both costs are going to be same. As these are going to be same, so you can say you have done it in a correct way. Okay, and the final thing is the percentage contribution. So using this percentage contribution, you can easily identify which material is going to be having more cost contribution, the percentage contribution. So let's start up with this, or else we can start from here also. This divided by this pharma CC, and let's try to convert this into percentages, and let's apply dollar for this total pharmaceutical cost. Okay, and similarly the formula is applicable to these things, and similarly here. And now let's try to add up these total things. So the reason why I haven't taken these key contribution materials are, I'm going to take this individually. Let's say here the key contribution percentage, the key contribution material Y, and its percentage is going to be the summation of these things. And also the key contribution material X percentage contribution is going to be summation of these things. As I am going to add up all these things individually, I haven't considered, and I have left these blocks unfilled. So let's see, this is plus summation of these things plus summation of these things. So this is going to be 100%. Now let's do some alignment things. Let's apply border so that you can see the sheet clearly. So now this is the raw material cost contribution sheet for total 3 products. So if you are able to see the last column, the percentage contribution. So from this, you are able to see that the majority of the contribution is being done by the key contributing material A, or the KSM A. That means it is attributing to total 68.63% of total costs. So if you are able to reduce, or if you are able to manufacture it in-house, then you can again reduce the RMCC, so that you will be increasing the profit margins. And similarly, let's say here you got almost 11.67%. So this is the second highest when compared to the KCM or KSM A. So in order to reduce the RMCC, let's try to recover this thing. So here it is 40 kgs, and as this is going to be having higher impact, I'd like to recover it. And if I'm going to recover it, automatically the cost is going to get reduced. So just hold it for a moment. Let's do one thing. So I'm going to recover it partially, like up to 40% or 30%. I'll take 30% recovery. Now see, the initial price is 3,184 rupees, and now it is 3,072 rupees. So there is a reduction of almost approx 110 rupees. So this way you can increase the recovery, or else these solvents are there, but the contribution is going to be only 1% approx, and here it is 2.25%. Let's do one thing. I'm going to recover it 90%. That is, I'm going to change 0.8 with 0.9, and now see, the price is further reduced. So this way you are going to increase the recoveries, and then you can reduce the total product manufacturing costs. Manufacturing costs in the sense, it is only with respect to the raw material costs incurred, and apart from that you are going to have the overhead costs. Overhead costs are going to be having the details about the total amount of utility that is being used, the total manpower engaged, and also the number of equipments used, and also the power costs. So this is how we are going to prepare a raw material cost contribution sheet, and also you can include the recoveries in this particular format. And by now I think you should have got a question like how to include the packing materials. So packing materials or also the outstreams can be included in this same format. So for that, what you have to do is just try to insert some more rows. So let's say I want to add some moisture absorbents like the silica gel pouches, and also I'll be using the polybags. So let's say this is going to be almost 0.02 times the KSM, and the polybags I'm going to take in number. This is, let's say, 0.05. So automatically it is calculated. So there is no recovery for this. So I'll be putting it as the same thing. So these are going to be 1. And now let's come to the price. So for this price, I will add almost 100 rupees. I don't know the exact price of this silica gel, and also I don't know the exact price of polybags. So I'll be taking it as 80 rupees. So once you have done this, automatically this will be calculated. So we shouldn't calculate it again. Why? Because you are going to insert the rows, and also here also I'll be taking the same thing. Just copy and paste. Just copy and paste. So here this is going to be 0 recoveries, and the specific gravity, let's say these are 1, and the costs are going to be same, 100 and 80, the unit prices. Automatically these are done. And even in this API we have to take more care. So I'll be taking as silica gel. These are regular poly bags, and here these are triple laminated bags. These are going to be numbers, and these things I'll take it as 0.02, 0.05, and this is almost 0.05. So these things are going to be calculated based on the bulk density, like what is the bulk density of the material and what is the total output here and what is the product volume. So based on the product volume we are going to identify the number of bags required. As these cannot be recorded, I will be taking as zeros. I will be mentioning the same here again 100, 80, and this is, let's say, 90. So here if you are able to see, there is a gap. Though these and these are going to be equal, with respect to cost everything is fine, but coming to the cost contribution, something is varied. Let's double click and check it. So these are need to be extended for these materials. So now it is 100%. In a similar way, if you want to add up the outstreams, that is, if you want to sell any of the affluent streams, in such case, in the similar way, you can include rows and you can mention about the affluent details, but affluents are going to be sold out. So sometimes you will be getting the money, or else sometimes you have to pay the money and then you have to sell it. In such a case, you can mention the price with as minus. So if you got 30 rupees, so mention it as minus 30, and accordingly the table will be recalculated. So this is how you are going to include the packing materials also. Okay, hope everything is fine and understandable to you. So if you have any questions, you can directly write a mail, or else you can comment in the below section. If you like our video, please subscribe and also please share with our dear ones. So thanks for watching this video.